Hello and welcome. I'm Greg Eva, and today we're going to be deep diving into some work that I've been doing lately, which I'm calling Mastering ThingWorx Container Runtime. This is somewhat of a culmination of many years of my experience embedded into a single place as PTC has decided to sell ThingWorx, and I will be staying with PTC. So this is likely the last video that I'll be doing on ThingWorx specifically. There's two points to this. I'm calling out the mastering runtime here in the title just because there's a lot of these aspects that really are just about mastering runtime operations for applications that you're putting into production. So really they're not at all specific to ThingWorx. At the same time, it is specific to ThingWorx because we're going to go deep into some of the things of how ThingWorx is configured, deployed, and managed. And specifically, we're going to be looking at that in the ThingWorx containerized environment using Docker and Docker Compose. So it's also got this kind of dimension to it of how the ThingWorx containerized world works. So let's get into it. First of all, I want to bring up DevOps because I think when I speak with a lot of people, DevOps is misunderstood and misrepresented. And I'm often hearing people like DevOps engineers talking about they're the ones that do DevOps, whereas DevOps is really a methodology, a practice, processes that allow teams to collaborate together in order to facilitate a seamlessly integrated development and operations cycles, hence the arrows that are integrating with one another. This is not only about technology, right? This isn't about I built an automated pipeline to do something. This is about how the teams can come together and discuss things like what they're developing and building, making sure that those other teams are getting what they need. And that obviously works easy to imagine with R&D and QA, but the same holds true for a cloud operations team or an SRE team that is going to need to work across the different groups. For that reason, this is really about the software development lifecycle. This isn't a question where we create an application and we just throw it over the fence and we give it to someone else, a host. However, that's often what we see, and that's part of the problem. So we need to think about how do we facilitate some of these interactions? How do we bring our experience forward so that we are facilitating these collaborations more seamlessly across the groups, whilst also ensuring that it's the appropriate team that is having the responsibility for the different aspects and is not being asked to do things that are not in their purview of expertise. So this interdependence means that the teams need to invest, or they need to invest further than just thinking about today for them, which is very self-centered view. They need to be thinking about the overall system and the overall life cycle and how the work that they're going to be doing today is going to be used and adopted by other people. Those other people are going to simplify their lives, and that means that those other people can come back and help them. It's a feedback loop that is self-reinforcing. And we need to ensure that that occurs because, unfortunately, lack of run operational phase preparation and such team collaboration is the main cause for production system issues. It's when things aren't thought of, they're not planned for in advance. People say that's going to be too complex or that's going to cost us too much money. And so it never happens. And unfortunately, once systems are in production, it's too late. One of the things I've seen over many years is something as simple as getting a configuration change into a production system can take months. And that is even if it's possible to get it in there, in which case it can be, significantly long. I have situations where it's more been like years. So these things need to be reflected upon when we shift left, when we move this thinking to the pre-production stages. A lot of these things are just non-issues. It's very easy to integrate them, and we need to find the balance between the effort that is upfront in a non-production environment that is easy to do and manageable, and the types of things that lead to issues in production environments that are quite costly and not possible to do in production. Okay, today's goals and objectives. I've been doing this kind of thing for a lot of years and working with a lot of different teams across this life cycle. And so I want to share some of that experience and kind of turn it into a little bit of some guidance on certain aspects. And this is coming from internal teams, cloud operations and engineering, as well as working with customers and integrators, as well as sharing some assets that I've developed, which will help and facilitate people getting started so that we can think about moving these things earlier to the dev stages, building these practices into just standard approaches for deployment, even if we are looking at just a dev environment. Key is facilitating this adoption and awareness and understanding as soon as possible so that we can have different stakeholders across the overall life cycle that are going to be cognizant at least of some of these approaches, even if they're not experts on them. The importance is that shared understanding, as well as providing some troubleshooting and debugging tools for different stages of the process. And providing, of course, some explanations as well as context around some of the things we're going to be talking about, because without that, it's very difficult to apply to your own projects in your own context. Okay, so somewhat of a long list of topics here. I'm conscious of this. This is going to be somewhat of a long video, but it does make sense when we string it all together. So as I mentioned, this is all going to be done using the Docker images, Docker containers, using the Docker files provided by PTC. So we're going to have a quick look at those. We're going to import them. We're going to have a look at the enhanced Docker compose that I've created, some of the things that I've added to there and why. Talk about a trial license just so we can get an environment up and running smoothly. Separation of the deployment and the environment configuration using an environment file, setting resource allocation, thinking about sizing, ensuring we've got diagnostics configured and enabled, as well as we've thought about monitoring, diving into the container itself and looking at the templatized configuration files that are used to build the ThingWorx configuration files dynamically at container start, doing some specific log configuration modifications and enhancements, as well as implementing purging for the log files. We're going to pick a couple of random configuration tweaks that we might do in a normal project lifecycle, and we're going to look at using environment variables to do that in this context and how that applies to those dynamic configuration files, as well as having to add them to configuration files manually. And platform settings JSON validator that I have created that is one of these debugging tools, as well as diving into some thoughts and enhancements that I've made to support container runtime debugging. Okay, let's dive into it. What have we got where here? So the first thing we're going to do is we're going to have a look at the Docker files. So this is an extracted view of the Docker files here from the ThingWorx downloads. And you can see the different compose for some of the different architectures or deployment methods. And we are going to be looking really at this one here, Docker Compose MSSQL. And just because I've been working with a customer who's using MSSQL as of late, so this is what I've been using. Typically, people use the Postgres version, but other concepts here remain the same. That's just going to be a few lines and image names that are different. So, concept of these is really, first of all, to build the images. And here we have the build m file where you can see Some of the versions and things like that of what are going to be taken are included. There's this build sh file. This build sh file is leveraged in order to run certain commands, which are going to do docker build. Those Docker builds are going to leverage the staging folder with some of the things that have been loaded into the staging folder, including ThingWorx itself. It's going to extract everything, it's going to mash it together into a couple of locations, and then it's going to take some of the secret sauce that is provided here. For example, if we look at base, I want platform base. In this folder here, platform base, this is one of the layers that is going to go into the Docker build. And you can see here we have a set of pre-configured files like the Docker entry point, which is a bash script, which is executing a number of things when the container starts up. We've also got some things in here like configuration files like server.xml, .j2, and these are essentially all of what comes together to create the container image, which is essentially a specialized implementation of our ThingWorx. And this is why we're using it, because there's a lot of magic, let's just say, in here that allows us to do some powerful things. I've already got the images built, and I have them in this folder over here that's just called images. So the image is already built. I've got this MSSQL init TWX, which is an initialization container for the database. This is going to set up and build your database for you when there is no database in place, so the fresh install. It's also going to handle the upgrades from one version of ThingWorx to the next. Platform MSSQL, this is the MSSQL version of the foundation. And security tool is used for managing the security keys, essentially doing the encryption and decryption and accessing the key store. All of these are available on the download site. Okay, so I guess first thing I'm going to do over here is, I think it's in the higher directory that I have my images. Yes. So I'm running, maybe just a quick, I'm running Rancher Desktop here. Not really a whole lot to say other than perhaps the preferences. Container engine, I am using the Moby Runtime, which is the default. And as far as virtual machine configuration, I've got 22 gigabytes configured for Rancher to be allowed to use, and 6 CPUs. These aren't the defaults. You're going to have to kind of knock those up probably on your system based on what you're trying to do. I'm also using a Mac M1. So this requires using Apple virtualization, which is hardware accelerated virtualization, as well as the Rosetta support. And this Rosetta support is going to support better emulation of the x86 AMD 64 architecture, considering that's the type of containers we're running. And once I have that done, I've got my resources, and I can essentially just come in here, and I want to get those images loaded. I think it's image load -I. And I'm going to do them one at a time. You know what, I'm not going to do them one at a time. Oh, it doesn't like that. I will do them one at a time. This Docker image load is a handy feature because if you do have a project you can that you've worked on and where you have specific versions, you can compress these tar files and then pull them back out later and not have to rebuild them, and also not have them take up too much space on your container registry or your local computer. Okay, I've got my images loaded. and I can see them here. They've actually come in with the tags already. So these tags are applied through the image build process, defined in the Docker build, everything there. And we're just going to use these default tags to keep things simple. So we're thinking about our future states. I don't really like these tag names, but the key is keeping things simple from one version to the next and making sure that our development workflow is maintaining and retaining some of these metadata such as tags. So that's what we're going to use. How are we doing on our list here? Import, export, enhanced Docker Compose. So let's look at the enhanced Docker Compose that I've put together, which was really intended initially just to be a demonstration, and I kind of got carried away, and it's a lot more than that nowadays. So this Docker Compose MSSQL is based on the PTC provided Docker Compose MSSQL, yes, which is meant to be an example of how you can think about running the containers, not for production environments, right? And PTC does not support running ThingWorx in production environments in Docker, as it's not intended. Docker isn't intended for production environments, but we do have more and more customers that are looking to things like Docker Swarm or Kubernetes and are on their way to getting to that production space using Kubernetes, but aren't there yet. So one of the things that I've done in here is I've taken my experience with Kubernetes and deploying and running ThingWorx on Kubernetes using Helm and Helmsman. And I've tried to implement a lot of those practices into the Docker Compose file. So someone who's starting to work with containers can use tools that are more easily accessible, like Docker Compose, and then essentially work on, bringing in the different competencies as progressively, as opposed to trying to take everything all at once. So one thing, maybe just as a first thing that I see here is this is Linux POSIX actually variable expansion syntax, which is really quite nice, because here what I'm doing is I'm providing a default value of the Microsoft registry for the SQL database if one is not provided. And this is a key aspect that I've implemented in this compose file, is we want to separate the configuration of the environment from the deployment. So this is more of a deployment file that's going to be used to deploy, that's going to bring capabilities, that's going to provide wiring to the internal container environment, but it shouldn't actually contain anything about the configuration or the deployment. Because if we have a dev environment, if you have a QA environment, all of those things should be held and managed elsewhere in an environment file. So by doing such a POSIX syntax for variable expansion, what we can do is we can allow the environment file to show up with an environment variable like this. And that means we can have different container registries for a different customer or for a different environment. So same for database ports. So the dash here means this is a default. So if we don't have an environment variable that says TWX database port, it's going to default to 1433. Otherwise, it will be whatever we provided in. And so that's one of the things that's drastically simplified this process. Unfortunately, the files that come from PTC have a lot of lines more closely resembling this, where we need to provide a whole bunch of prerequisite information, and that prerequisite information, you have to get it right or it's not going to work. So here what I've done is essentially provide a lot of default values for things that you don't actually need to change, and we typically don't change, like twadmin for the username or ThingWorx for the database schema. These are just things we typically don't really care what the ThingWorx database is called, and ThingWorx is probably great. So by using defaults like this, we don't need to feed it in. Okay, there are some things that you definitely do need to get in there. Database admin, ThingWorx, the passwords, because some of the passwords, like the initial passwords, initial passwords are just an initial password. You're going to change those after the environment gets stood up. These types of passwords are not. So you definitely need to be coming up with these passwords. If you don't put the passwords in, it's not going to work. Okay, what else? So I've also added this as I've been running this on my Mac M1, just stating that these containers are running on a Linux environment. So it's telling the container runtime or the Docker engine that these are using this particular platform. And if we have a look at here in the environment, I have a lot of stuff in this list. You can see there is a very long list of configurations, and this has actually been a very long part of putting this together. Is what I wanted to do is take essentially all the configurable variables from inside the container and expose them here in the Docker Compose. So if you're a developer, you're an integrator, that you're needing to do things with the composer, you don't have to be intimately familiar with all the configuration files, all the different things. You come to this list, you look for the section, you look for the name of the thing, and you can already start to do something. So obviously this means you're going to still have to dive into it, but the intention is that you're diving into the subjects that you really need to be diving into, not wasting time with everything. So I guess a couple of basics right here. Tomcat configuration. I mean, these are the classics running on a web server. It's Tomcat. We want to make sure that HTTPS, we want to choose what we want to run. If we want HTTPS, if we want to change ports, where we're going to set key stores up. And these things, this is nothing different than in the normal process for setting up ThingWorx. We're going to have a look at some of these dynamic configurations afterwards. Some other logging things. These are some nice things with the container runtime where we can turn off console logs. We can change the maximum logging level to console logs. We can even use JSON logging. If we have a system like Splunk or Sumo Logic or Elasticsearch that might be collecting those logs in JSON format, might be more appropriate from the console. I guess there's a lot of configurations in here. I'm not going to go through all of them, but there are some of them here that I've put in here. We'll see them again in a second, but these two are kind of configurations in the product that shouldn't be this way. It's a question of understanding the balance between what you want your application to do and how you want it to behave. These two logback settings are actually defaulting so that logging is the priority above actually running the application, meaning if we have a lot of logs that are coming out of the application, maybe there's some errors that are being emitted. If logback for some reason is unable to log, imagine we lost the storage volume, or just the rate of logs coming in is greater than the rate that we can actually write them to persistent IO, it will block the application until those logs can get written. And that obviously means unavailability of the application. So typically, we get to a point where we want to prefer running the application as opposed to logging more logs to a file. If we have gigabytes of log files, having more gigabytes is typically not going to get us anything more advantageous. So here, the never block is telling logback, don't block the application. Essentially throw things on the floor if you have to. And then the discarding threshold is all about when do you want to start discarding things. So we'll see in a second when we look at the environment file. Discarding threshold, I have set it to 20%, which is the default of logback, but it's not what's in ThingWorx, meaning that when there's 20% of the remaining space free, then it will start to stop logging, debug, and trace messages. So that's quite clever. Focus on getting warns and errors and infos into the logs. Make sure that someone can't take out the application accidentally by turning on trace logging, and then we can't keep up with writing trace logs, right? So some of these things are just settings. And that's an example of the types of things when you're running these types of applications in production. administrators or engineers that are deploying these things need to be aware of these things, because they're very dependent on whatever the application is doing, how much load that it has, what are the underlying provisioned resources, because going for cheap resources are not going to be able to handle high log ingestion, and hence could put your application at risk. So can't look at things in silos. All right. What else do we have here? Prop right. I mean, that was kind of what I wanted to say. Down here, I have a number of volume mounts. We'll get into this now, I guess. A number of these volume mounts, what I've done is I've gone in and I've pulled some of these configuration files out of the container runtime. If we kind of come back to here, this Dockerfile section, platform base image files. In the various locations, you can see ThingWorx platform settings. Here we have a logback.xml.j2, and so this is the logback configuration. We were just talking about this particular one, JSON logs enabled. And this is how this actually gets into the system, is that environment variable is set here, and it's set to default false. But this is how it works its way into the application and getting to logback. Similar with if we want to turn something like console stack traces off, this is where it's going into the application. And here's that the discarding threshold and never block, where we're telling logback how we want it to behave. This file is actually a Jinja file, a J2 file, meaning that it is a templatized file that is going to be rendered at container runtime. And so certain things like environment variables here, that will be rendered by the template processor. There's a number of other things in here. If we look at this type of if conditional statement, this is going to, depending on the value of enable clustered mode, it will generate a different logback configuration file, knowing it's running in standalone or it's running in HA mode. So this is super powerful, and it is essentially how all of the configuration files in ThingWorx run, is using these J2 files, where the J2 files have some of this Jinja templatized. It's not full Jinja, but Jinja inspired template processor, which is going to render these at runtime, sometimes merge them together if there's multiple files. Like here we can see there's platform settings override base and platform settings dash customer overrides. This one is empty because it is intended to be used when a customer or a person who is leveraging the application says, hey, I need this configuration added, I need this configuration added. Whereas this overrides base, this is a generic override file for generating the standard aspects of the platform setting file. And we can see here, we've just got a line that says, some of these things we saw in the compose, disable metrics writing to application log. If we were to put a true value in here, then we're just going to set this entry in the platform settings file. So super simple, but super cool, because it allows us to essentially really separate this notion of I have to build a whole configuration file and then manage those configuration files from one environment to the other. And then, those configuration files, when I get a new version of ThingWorx, well, I'm going to have to go back and refactor my configuration files, because there might be new things in here. Like the one thing I was going to show you is actually not in this file, but I can find it down here. I have implemented it in this. So I've made a customer overrides file. And so here I've got some things in the customer overrides file that we're going to load in so that we can get access to some of those configurations in the platform that aren't natively built into the container image build process, but that we can add in here. So by separating these two things is when we do a platform upgrade, we go from 9.7 to 10 to 10.1, whatever, we don't have to touch the configuration files, because if there's new features that come in the 10 version, Well, those configuration files in over here, this one here, this overrides base, that's going to be modified by ThingWorx R&D team. Okay, so this is where super powerful because of the separation of all these slices of these configurations. Well, we can allow PTC to enhance functionalities and just make it available with an environment variable. And then if one day we need to leverage it, well, then we can do so. Okay, so I mean, we talked about Jinja. Okay, so this template processor, I'm not going to show you how it works. I mean, it pretty much, there's a source and an output destination, and basically they're rendered and then they're put in a temp location, and then they're moved to their final location where they're going to reside, you know, the slash ThingWorx platform slash platform-settings.json, and that's where the application is going to pick them up. Okay, let's talk a little bit about, maybe we'll look at far easier to do this in VS Code than to run the environment. But there is one thing that's pained me over the years, which is getting the license in order to get some of these dev type practices set up. And in digging into these things, I noticed something in here. Where is it? License. Yeah, this block here, this is license file equals opt trial.bin. In the documentation, there's reference to trial licenses. However, this doesn't actually normally work when you just take the Docker Compose files. And the reason is really just a question of some environment variables. I believe it's this one. This environment variable needs to be set and not false. So basically, you just need to have this use trial license environment variable set to true. And instead of, you know, it will, let's say this differently, it will pull this file in and use that as a trial. Okay. I guess the challenge is you can't also mount a license file and say I want to use a trial, which we can see if we look at the compose down here. I have commented out this license file line specifically for that purpose, because here what I'm doing is I'm taking the file that is right here, this license.bin, and I'm mounting it in, taking the license name, which is set in the environment file, and I'm mounting this in to the varders ThingWorx platform settings, ThingWorx license name dash bin. This is where it's going to be pulled and copied over. But if when ThingWorx starts, it sees that there's a license file here, even if it's invalid and it's not the one that you want to use, then it's going to prefer this file over the trial. So if you want to use the trial, basically you have to comment this line out. And then what I've done up above is, if we look for the trial license, that use trial license, here you can see that I'm actually essentially setting this to true if you have not provided a license name in the environment file. So this is just a simplification, trying to say, look, you're trying to get a new environment set up, a dev environment, whatever. If you don't specify a license, this thing is going to activate that to true. So you can see that this is just a tiny little thing, but it's the kind of thing that every time we as IT professionals, we stumble across these kinds of things, it costs us a half an hour. It costs us an hour to figure out what the heck is going on. And that's where, that's also why I'm explaining this, is so that you can be cognizant of some of the things that you can dig into to understand what's happening at the container start, but at the same time to simplify and make it a lot more usable. Okay, so I guess with that, we are looking at these environment variables. In the mount, down at the bottom here, terminate license name. So if you have provided a license name, it's going to mount that in based on the license name that you provided here. So the license you need to have in your directory unless you want to change this and pull it from somewhere else. The reason that I've variabilized this is, as I said, environment and deployment are separate things. You don't want to change the deployment in order to have to change the configuration of the environment. And because we do this kind of request response process for the license creation and generation, we're going to get this license request capabilities file. And so we need to set this license name to something along those lines. We're going to get the file, we're going to download that file or the host ID, the triad ID, in order to put that into the system to generate a license for us. We're going to get a downloaded file. We can put it in here, and then we can just update the environment variable in our environment config. So we've been talking about environment files and details. Time to jump into those. Here you can see in the environment file, it's a lot less confusing than looking at the Docker Compose. That's one of the challenges when we wire things up to be quite capable and complete. It's going to be long and confusing. So here what I've tried to do is kind of break things down into sections by providing the defaults in the Docker Compose. Basically, we can take the environment file, and the goal is to just make this as minimal as possible so that we don't have to have kind of placeholder environment variables that I might want to change one day. I can just essentially delete anything that is extraneous from this file, and it will pick up the default over here. So the really nice thing about using such an environment file, if you're using Kubernetes, you'll be used to such an approach with like a values.yaml or something like this, is that we can source control and merge and validate and commit things with comments so that we can see who's changed what on the environment, and that is incredibly powerful and can allow us to essentially look back through time to say, oh, that's interesting, database CPU requests, it's half of what it should be, what's gone on here. So here you can see that I am stating the requests and limits. This is something that is, I guess, relatively new in Docker. I guess it's version 3 of the Docker Compose. So this is something we do obviously in Kubernetes with requests and limits. So I'm actually just picking up the same naming convention that we use in Kubernetes with the Helm charts for things like the sizing of ThingWorx. Where's ThingWorx? Resources. TWX CPU request, TWX CPU limits. And in the deployment block here, you can see that we're defining in the compose file the different resources with some defaults. So this is just an example of, we're going to have multiple environments, right? So having just these few lines where I can quickly configure how much resources I want to provide to those different containers, and then have things adapt from there is extremely powerful. And defaults with that as well. Resource allocation and sizing. I guess we're kind of driving into resource allocation of files and environment file and defaults. Yeah, we've already talked about defaults, environment files. So resource allocation and sizing. So if we come back to here as a kind of a continuation of this, I do have some defaults in here. So this is going to take a default of 1 CPU, default of 1 gigabyte, with the intention that that's, pretty small. You shouldn't use those. You need to specifically set it. But if you just need to get an environment stood up, I was going to say it should work. Should work on a dev environment, and then the intention is in an environment file you would set more specific values. Because we're setting them on the container, this means that the typical guidance, which is to say you need to adjust your heap and you need to set your heap based on your deployment. So your Java heap size, your minimum heap using like XMS and XMX for maximum heap size. I've done away with that, and I've switched over to the containerized approach of doing this. So over the years, Java hasn't really supported containers so well, and has certainly not been designed for adaptive sizing and use of resources like we get in something like Kubernetes. But over the years, some of these changes to Java have come. With ThingWorx 10 and even 9.7, we're using like Java 21. And so we have these initial RAM percentage and max RAM percentage that are going to take essentially the maximum value from the container and going to determine how much memory we can use. It will determine the heap size based on these values. Okay, so because of the fact that these are percentage based, you can see I've put defaults of 40 and 75 in here. We don't really need to think too much about it. And it's just going to determine this based on what we've provided over here. The CPU requests memory. It's going to take those values, and the JVM is going to determine and calculate the heap sizes on its own. While we're right here, we'll have a look at this, and then we'll go run it and see. Max direct memory size. This is a new one that isn't really documented anywhere yet, but this has turned out to be a thorn in our side for many years, where Kubernetes is killing pods. And this is because certain libraries that are seeking performance, they use direct memory mapped buffer pools. So things like Apache Ignite or Netty or even Vertex. These are libraries we'd use more in HA for Ignite, but connection server, eMessage connector use Vertex, and Netty is used in the connection servers as well as in ThingWorx. And basically what can happen is that we're defining a maximum heap size, and so the JVM is managing those memory pools. But the whole point of direct map memory is that the JVM is not getting involved. It's not doing any garbage collection on the direct map memory spaces. And so the direct map memory spaces or buffers can build up to the point where we actually exceed the allowed limit, and we'll get an OOM kill because we're using too much memory. And this is because Java is taking the max heap size, and it's also applying it to max direct memory space, which is kind of a bad calculation to do. So here what I'm doing is I am saying we are going to cap the max direct memory that we can use. Here you can see I've said 512 megabytes just because I don't think people are going to come and fiddle with this too much. So we need kind of a higher amount because direct memory for performance is going to be super important. But at the same time, if we ever need to adjust it, because every application is going to be different, if we need to adjust it, we've got this environment variable there already. So we can just come in here and change it somewhere, like right here. Let's do it now. Uncomment that. So we said 512 over in the deployment file, right, which is a good default. And here, if we're getting ready to deploy this to production, we just have to throw something like this in there, and that should reflect directly. All right, so let's deploy this thing. Compose. Okay, so here I've got a Docker compose .yaml, and we're going to say up. Using the env file that I've just had open there, so I'm passing in the env file. It'll do this by default if we have a .env file, but unfortunately it's a hidden file, so some other tools might not pick up that hidden file. So here we're actually using a specifically named file, so that you can manage multiple environment files within the same folder, specifying the docker compose -mssql. Similarly, if we just had docker -compose.yaml, we wouldn't need to specify this, and we're going to hit up. Actually, I just need to check quickly a couple configurations that I may or may not have changed. Yeah. I'm going to remove something from here, which is this, 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 and leave that. Okay. Let's stop it again. I might have broke it. One of the things when ThingWorx sort of starts and builds for the first time is that it's doing a whole bunch of stuff. It's going to create a database. Given the password that you pass in, it's going to make some secrets. It's going to generate those secrets and put them into the secret key store. And sometimes when the database creation process doesn't succeed all the way through, it can create a situation where it thinks the database is there. It is kind of there, but it's not actually set up. So the user is created, but the database isn't set up, and it'll just kind of get stuck in a loop. So that's why I just did what I did, is to just clean it up and then try it again. So it's deploying MSSQL from the Microsoft registry here. It's setting up the database, and now you can see the security CLI container, which is started. It's creating the key store, adding some of the details. That volume is also mapped over to the ThingWorx one, and here you can see MSSQL init. So it's saying database, instance, port, username, database. Okay, we're going to connect there. Platform is getting connected. It's running through all of its things. It's getting started. It's doing stuff, and it's starting ThingWorx. So this was quite quick. I've only got HTTP connector enabled because I don't have certificates set up. But basically, I mean, we're pretty much there. Start loading model, and it's almost done. And let's find Chrome here. We're going to need the password. This is where I was mentioning the initial password. It's going to come from somewhere right here. ThingWorx initial admin password. Okay, something's wrong here. Just let's go and check it out. Authentication filter. Oh, it's locked, that's why. Oh crap. Okay, let's just destroy it and start over. Normally I would save these kind of credentials as I'm working through this. Basically my first attempts seem to have locked the administrator user out. And while we're doing that, getting ready for the next part, so we talked about resource, yeah, right. We do want to come back into this container. Okay. Yeah, so when this comes up, we're going to go in, and we were talking about resources. We want to make sure we kind of close that topic, and we're going to come back and we're going to have a look at the resource allocation that we have essentially stipulated in our configuration environment. Maybe one thing while this is running through, one of the nice things is I hate managing secrets, doing the encryption, using the security tool, getting those into the key store and everything. Because this containerized approach is all automated, once it is a pain to work with, but once you do get it all set up, it's just a question of you wire in your variable, and it's going to generate those encrypted secrets and put it in the key store, create the file for you, put it in place, give access to the containers. So it is a lot easier, frankly, at managing multiple environments when you have encrypted credentials, because you don't have to kind of go back over it afterwards and make sure that things are encrypted later on. Docker. So we're going to just go into the container here. So now we're in the ThingWorx container. You can see process 1 is Java. And if we pipe this to more, we can essentially see all of the command line parameters that have come in with Catalina as it started. And I want to see something specifically. We talked about resources. So we're going to have a look at JCMD process 1 VM.flags. Pipe to TR. Replace the spaces with new line characters. So here we have all the VM flags, and you can see some of the things like max RAM percentage. These we passed in, and so we've got max heap size. Basically a bunch of these memory pool sizing details are coming from calculations based on the max RAM, based on those percentages that we've provided. And you can see the 75 is essentially calculating from this 8 gigabytes that our heap size, max heap size is this, and our initial heap size is this. So that is working. We also should have the direct memory size in here as well. We said 1 gigabyte, and there it is. So basically what I'm doing here is I'm asking the JVM, what are your understandings of some of these things like the regions when you're troubleshooting memory performance issues or memory sizing? You really have to come in and ask the JVM, because although you might find some of these details in the logs, it's creating the database here. That's a little bit long. How far up do I have to go? Quite a ways, I think. If we do look in the logs here, when Catalina is starting, you can see that these command line parameters are exposed in the logs. And so we can see the some of those things that I put into the Docker Compose, initial RAM percentage, and this max RAM percentage, max direct memory size. So, to be able to troubleshoot things across the different stages, make sure you've got it in your configuration, make sure it's getting into the environment, make sure it's coming up and being read by Catalina, make sure it's actually getting into the JVM. This is the kind of thought process and why it's important to understand how some of these things work, and also why I'm going through this, because if you're troubleshooting this stuff and you have no idea how it works, then I've seen this with many colleagues, you're not going to be able to make any progress, right? You have to get into the details and understand how things work. Okay, resources. We could also do something like look at CPU info. So here we have a number of processors that are defined. What is that? 6 processors. Not actually sure if we have access to all of those processors, but if we check our environment file, we should be able to see 5. Yeah, that's why we had 5. Limit is 5. Okay. Oh yeah, we destroyed it and started over. It's my problem. I didn't get the T. in. And we can just check. Just going to run get performance metrics, and we'll see memory in use, total memory allocated. There we have our allocation, which should really relate to around 4.75 gigabytes, which should relate to our no license installed. Yeah. No license installed because we're using the trial. That's why we're getting the stack trace. And our initial heap size is 3.4. So it has grown a little bit. And I guess that's a good opportunity to move on to the next topic, which is diagnostics and monitoring instrumentation. So one of the things that I struggle with people over the years is, I don't want to say they don't listen to me, but they don't understand the importance of monitoring. And when I insist on monitoring, it's because you monitor production applications. You don't not monitor. This is one of those things I was referring to. You don't just push everything forward, get it into production, and then come back like a year later and say, oh yeah, boy, we should really set up some monitoring. So this is something that I've built into this deployment with the mindset that if you're a developer, that you're developing some code, you need to know how that code is running, because you understand how it's working while you're building it. But then when you're going to finish your work, you need to know how it behaves. When you know how it behaves, when there's complaints or there's problems that come up, you can compare to that baseline understanding of what you expect of it. And unfortunately, most people don't have that baseline. And you need monitoring and diagnostics and performance tools in order to capture that baseline. So what I've put in here is there's a few files over here. I've pulled JMX Prometheus Java agent 0.20.0.jar. This is essentially a JMX exporter for Prometheus that's going to expose JMX queried MBean attributes from inside the JVM. It's going to expose them to Prometheus to come along and grab them. And this is something that I've built over the years, where getting some of these metrics from JMX MBeans, and I'm generating them into ThingWorx persistence provider metrics that aren't available directly in the platform for the database things, for various things for Catalina. So we understand how Tomcat is working, number of requests, latency of these requests, number of connections to, as well as Java. Super important to understand how all these things are operating across the different layers of the runtime architecture. Okay, so this is the configuration file. This is the agent, and I am mounting this in. There's a couple of mounts down here where we're saying, look, here, whatever you have provided, either it's going to take the defaults for those files that I have on the left, or if you want to say I want to use a different configuration file, I'm working on adding some things, removing some things, whatever, or I have a different version of that Prometheus Java agent, then use those environment variables. And how does it manifest? It's pretty straightforward. It looks, oh yeah, I didn't put it in here. Oh no, there it is, yeah. It's another thing I didn't put in here. It's just further on this Catalina OPTS line. So if we were running a different sort of Java application where we didn't have this Catalina OPTS, normally we'd pass this in, something like a Java OPTS or some other way that we can get Java options to the command line. And basically all this is doing is it's loading that jar file in as a Java agent, and that Java agent is going to get certain things about memory pools, about thread states, about internals for the JVM, and it's going to expose them on a particular port, which is 9111. by default. And so let's go have a quick look at that. 9111. I can't recall if I've mapped this out. I guess I have to map that out. So if we just go over here and say like localhost /metrics, that's great. Yeah, okay. It's possible I'm not on the same, I'm not on the Docker network, that's why I can't get there from my computer, but I can do it from in here. If we just kind of look in here, curl. Okay, that took a little bit of time. It's because it's going and doing all those JMX queries. And basically you can see here, JVM memory pool bytes used. This is the code heap. G1 Eden space is a young generation. It's telling us what the value is. Catalina request processor. This is what I was referring to about the Tomcat metrics that I've got exposed here too. Request processing time, so we can, understand some things about how long it's taking to process different types of requests from different servlets. All sorts of great stuff in here. While we're in here, there is also one of these for ThingWorx, right? This is, if you're not aware of this, I've done a ton of videos on this in the past. But basically, if you come into ThingWorx /metrics, this is the standard metrics endpoint that basically you point Prometheus at this endpoint, you point Prometheus at the other endpoint, and that's pretty much what you have to do. That's it. And you'll need a couple of dashboards as well to interpret these. A colleague of mine is actually working on a Docker Compose deployment that you could bring into something like this too. Which would auto-deploy those dashboards. Grafana dashboards. But even the dashboard deployment is pretty straightforward. If you just go to here, you can see there's an ID here, 19533. I believe the 3 dashboards that are in the kit are 19531, 19532, and 19533. And you just have to say import dashboard, put in the number or point it to a link, and you're going to get things like this. You're going to get things like the Java one is extremely helpful here on Java overall performance, and Tomcat. The Tomcat one is quite nice as well, really for runtime environments, maybe less for dev, but for runtime environment, you can see here that you can immediately see how many connections you've got to the server, how many requests you've got coming in, how many errors, as well as how the threads in the Tomcat thread pool are behaving, how they're handling those requests. So that's super powerful for monitoring Tomcat, which is essential as you put a web application into production. Okay, we're not done with the monitoring and diagnostics. There is what I was referring to that I thought was in here that is actually elsewhere. This is kind of a deployment specific, right? As I said, in my view, you should never deploy any application without monitoring. So that's why it's pre-wired in here. So you don't have to make a choice to say, should I set that up? Do I set that up? Who gets that? Everyone gets that. And that way you can compare between each other, right? R&D, QA, integrators, implementation team, monitoring team, architects. But if we come back to the dev config here, this is more of a deployment specific thing, right? Might want to say, do I want to have additional logging? Do I want to log things in a particular place? And I decided to put this particular thing here because for me it is essential, but it's also specific to a particular environment. So if you had garbage collection logging, which is what this is doing, is it's enabling garbage collecting logging for your JVM so that you can monitor JVM, how it's managing your memory, doing garbage collection, your different memory pools and the like, I can put it somewhere. So here I'm using some defaults based on the platform ID and based on the ThingWorx storage. So it will go in with your ThingWorx logs to the environment. But if you're in an environment where you're using some other log collection tool like a Sumo or Elasticsearch, or you might not want it to put them there. You might also have some specifics for volume mounts that you want to do. So basically I made this as a part of the environment deployment. You can see here that this is going to log time, level, and other metadata tags in there. It's going to keep a maximum of 10 files. It's going to rotate those files, maximum file size of 100 megabytes. And so this means that you can go and get some history between JVM restarts, and you've got timestamped information so that if we want to do an analysis and we want to compare that to some logs, the timestamp is essential, because we can look at this particular time, we saw some slowness, we saw some strange behavior. Giving us the garbage collection logs just really immediately allows us to be able to go in and see, look, we've got high garbage collection activity, excessively long pauses for 5 minutes. You have your answer as far as what's going on, right? There's excessive memory use that's leading to high garbage collection, that's exhausting the CPU. That's something that we see just over and over and over again. And most times people don't have this logging turned on. So it's just invisible. It's the kind of thing that you could find in 30 seconds if you had the logs and know how to do it. Okay, so let's look at those garbage collection logs and what they look at. I'm still in the pod. One of the things is that on that live dashboard that I've built and provided there, you can kind of get some of those similar information on garbage collection, on load, on thread states and things like that, but it's not as precise, and you can't really share that with tech support. And that's where we come into the logs. The logs are the key for understanding really things that happen at a specific time, and also being able to zip something up and put it in a corner, whether that be for your baseline or whether that be for something you're investigating, or to share with the software vendor, tech support, or whoever. If you don't have logs, then it's going to be very easy to just get lost and not have the diagnostics that will give you the possibility to dig into something later. So here, I didn't really show it, but I did try to use some environment variables here, and I've started it by the file name by GC, so that if we wanted to just look in the logs, we could kind of go gc -star, and we'll see all the different garbage collection logs in here. And basically one of these is running right now. And if I wanted to look at it going, this isn't going to be very exciting, but because there's nothing happening on it, maybe we'll just open it up like this. Okay, so there's a fair amount of information in here, but this is what's coming with that log level star, in that we're having the info level GC logs. We're seeing things like details, like what kind of pause it is. We're seeing the different types of regions that are doing certain things: Eden space, young generation, old generation, survivor space. So we're seeing some things like this is how much CPU. So if we were to filter by CPU, we'd be able to see how much CPU and the different types of CPU that are being spent executing the garbage collection. And as I say, this is really the kind of information that engineers that are looking into this and looking to optimize performance of the JVM and track down application issues. This is the kind of thing that is hugely valuable. Okay, so monitoring, instrumentation, diagnostics. Yeah, we've certainly got some other things in here. I mean, can't not mention the access logs. The access logs are going to be very valuable as well. I use them all the time for performance troubleshooting and things like that. We don't really have any requests yet on here. I guess what's the date today? The 25th. Yeah, so these are mostly the health probes, but we do have request timings in here. I guess we'll get into that because that is relevant. cat. There we go. So this was me when I opened the ThingWorx/metrics URL, and interestingly, what we can see is not only the time that I did that at, the method that I used, the request that I made, the thread that I did it on, and the session ID, my session ID. So the reason I've put session ID in here is that if we had lots of users that were using the system, once again, back to thinking about production, this doesn't matter in 80% of the situations. But if you have 1 or 2 users that are complaining about something and you have 100, 200 users, you're never going to be able to make sense of these logs, because you can see they all have the same origin IP address. This is a unique piece of information that's associated to the user session that you can use to filter out and just look by user session. And you can look at things like this latency. So this is the latency, service execution latency of this particular request. And so we can look at patterns over time. We can dig in based on this type of thing. And this is historical as well, right? So this is put in context with the garbage collection logging. It's an extremely valuable way to look at performance over time. And because we're just switching a few things on, then this is all of a sudden available the moment that you need it. Not the typical situation is where we have to kind of come up with a checklist and we say, please turn this on, please configure this way, please do this. And then the answer is typically, well, that's going to take us a couple of weeks, or it's not possible for us to do that in production. So then we don't have the appropriate diagnostics required in order to dig into the problem. And the problem then persists, and all because of we didn't think through the diagnostic process as far as what do we need to be able to support and diagnose the system. Templatized configuration files. Okay, log configuration, purging, yeah. Templatized configuration files. So I showed you this one already. This one is, as an example here, I've just added max statements, max pool size. These settings here, they're going to come up in ThingWorx. Going to come up in ThingWorx in the ThingWorx persistence provider. ThingWorx persistence provider. Here, these settings, configuration, initial connection pool size 10, acquire increment 10, max connection pool size 100. Okay, these have to be configured in the platform settings file because they are determined by the connection establishment to the database. The database is going to be used to load the data, so you can't change that in the platform. As I mentioned, previously you might have to go and add some things into the files and then do all these things. Let's just kind of do a quick demonstration of what happens if we want to change some of those settings. So because I have, let's just say the key ones, I don't have them all wired in here on that particular page, but I have the key ones for the ThingWorx database connection pool provider wired in here because the default settings are horrendous. So this is 5. We already know that the system that we just looked at is not using defaults. So if I just kind of go minimum pool size, let's say the minimum is 10, initial pool size, we'll leave it at 20 and then leave that there. Acquire increments, we'll acquire, so when we need new connections, we'll take them in groups of 15. Maximum pool size is fine, max statements is fine. Helper threads is fine, initial min pool size. So basically we're just going to increase the min pool size to 20 and let's go back and restart container. Partially using this example as it's a simple one. It's one of those, I guess it frustrates me a lot. When we put defaults in place in the product and we say, look, you have to go and change these for your production environment, what we actually see is that people never change them. So the intention is to say my application, my use of that application, my intended load, I mean the type of database that I'm putting behind that, it's all going to have some specific characteristics to it, and something we have to put this small. For example, this value that we're changing, we have to put it small because if we were to put it to be 100, then on your dev environment, you wouldn't have access to 100 connections because it's going to be a small database, and the database is going to determine that. So that's where, a lot of these settings, we actually have them so that they are kind of tuned already for production, but some of them aren't. And that's where, teams, and that includes developers and sysadmins and ops teams, need to understand something as basic as, connections to the database. Do I have enough connections to the database? Are those connections in place and available for use when the application needs them? Because if they're not there, then that means that the requests are going to be waiting. Okay, and let's I didn't save that. Perfect. Okay, so we've got the acquire increment that's changed to 15. The initial connections were 10, and minimum connection pool is 20. Very exciting. There's a lot of stuff that's going on under the covers to make this all happen. I'll take you in there, show you around a little bit. Okay, so there's this file here, template processor. I mentioned a template processor. And here you can see that this has just got a JSON file that's loading the commands that's saying, look, here's the template file, here's the output file. Okay, so it's going to go, this is this at varders at ThingWorx platform setting. This is what we saw from the container image builds that's being brought in. It's the template file, the J2 file. And this is that base one that we looked at that is including essentially all of the platform base image files, varders. Platform base, this one, right? So it's got all the Jinja in here. It's going to say platform settings, config, basic settings, backup storage, ThingWorx storage location, all of this stuff. It's going to run this and output the file here, and then it's got this long list. You can see it's doing all this Jinja processing, this template processing for this file, and this file, and this file, logback, and logging properties, and server XML, and web.xml. So there's a number of things in here, and basically when this runs, how does it run again? Don't think we need to really run it. We'll have a quick look at the code. I'm not going to run it, but basically when this runs, it is going to generate those files. It puts them to this temp location. It's going to later move those files out of there, and then it's going to transition them into their final location. What if we go into ThingWorx platform? This is a critical one, obviously, for ThingWorx, is the platform settings.json, and you can see it actually just kind of does some copy all files. So it actually ends up copying the J2 files in here as well, even though they're not used. And so you can see that there's two. There's the template file that's copied over here, and then there's the rendered actual configuration file, so the XML in this case, and then the JSON in this case. And for this one, this is the most complicated one, there's some merging that needs to go on for a couple of these files, because, for example, we have the reference. So this one here is the reference that contains essentially the reference settings for everything. And we're generating a number of these files. Platform settings overrides base, platform settings customer overrides. So imagine we had one of those settings, one of those values that was set in multiple places, or we have to merge different parts of the JSON structure. That's where we're going to use tools like XML merge for the XML files, and JQ for the JSON merge. This is where we're getting into the kind of the weeds on some of the power that's behind this. Let's look at the plug that in. Dockerfiles. Base. I guess it's in platform. There's the Docker entry point. So this is what's being run when we start the container. And we were talking about that template processor. So here is the command. Essentially, we're setting some folders, some locations for those temp paths and where the things should go. And you can see here temp Catalina dir temp platform settings dir. We're going to create those temporary folders, and then we're going to run this opt template processor, bin template processor run commands. It's going to pick up the configuration file and run through those things. And then here there's this JQ-S, which is essentially taking these different files as inputs and is going to merge them together, and it's going to redirect them to an output, which is the merge result. If you have ever had the joy of working with this particular process, it can be kind of a nightmare, because what happens is if you've gotten any of your J2 files wrong, in that the rendered templated file is not valid JSON, or in some way, shape, or form, once it gets merged, it won't merge properly, then what will happen is you will end up with a file here that is not a valid platform settings JSON file, or not valid JSON, but you won't find out about it right away, because the process just kind of goes through, and eventually ThingWorx is going to get started. Tomcat will actually start. If it's related to the platform settings, Tomcat will start because it doesn't require this. So we're getting through the process, we're getting things started up, but then ThingWorx requires this, so it's going to try to open that up, and you'll have a halt, a termination, because of the fact that there's something wrong in the file, and it might say something along the lines of line 341 has a problem. Unfortunately, because it has merged in this reference file, which is extremely long, and it's merged this in, and it's merged this in, and it's merged this in, this 341 is completely unrelated to anything that anyone has done, right? So you really need to kind of trace this backwards in order to understand how you can find the problem. We'll get into that later. Templatized configurations, logging configuration, and purging, right? So of the templatized files that we have, there's some of them that are lacking some configuration settings. And specifically, I'm going to talk about server.xml right now, which is one that I have an enhancement request in to R&D to add this particular parameter to the access log valve for Catalina. And basically what this says, and this is not a default, it should really be a default for Tomcat, but there is an infinite retention period by default for Tomcat. And by applying this max days parameter, basically Tomcat will clean up these access logs for us. And considering access logs in production, you know, from systems that I've seen, they can be 100 to 200 megabytes a day quite easily. You know, over 30 days, these access logs will build up to be quickly gigabytes, and depending on how we're hosting the environment, if they're never being cleaned up, then this is the kind of thing that, as I say, people don't necessarily think about, and they're not necessarily rigorous enough to be keeping tabs on these sort of things. And then we run out of disk space, and we kind of scratch our head and go, that's weird, I thought 100 gigabytes was a lot. Maybe it is, but if you're never deleting the log files, then, you know, nothing is ever going to be enough. So this is why I have applied this in here. as essentially an enhancement to this server.xml.j2 file, so that we can tell Tomcat we want to make sure that you're not keeping logs indefinitely. I put a default of 60 days, which gives us a couple of months to be tweaked depending on the environment that you need. While we're here, I also added this access logging pattern, which does a couple of things. One is it removes the %r, which includes the query string, and then creates a situation where we can possibly leak secrets, because if we are passing any secrets over the query string, obviously we shouldn't be doing that, but we do sometimes see customers doing that when they have old equipment. They can only pass secrets that way. So this way, that'll keep those types of secrets out of the logs. And we've also added the %i and the %s here. And this is the thread name and the session ID that we saw in the logs earlier. Once again, it adds a couple of extra columns, so extra disk space, a little bit of extra data I/O. But when we do have to troubleshoot and dig into identifying some particular issue, being able to have the thread name that we can correlate to something that's going on in like the script log or the application log, it really gives us that bridge between Tomcat and ThingWorx. And I think it allows us to look at things from a time and a thread and an execution perspective, as well as a user perspective. So this is a environment variable that I have created that is in the, that's mapped through here. You can see it here. And that we could then just go and change somewhere in here, in, yeah, this section right here. So if I uncomment that and I say Tomcat logs max days 3, then I restart this, then we should be able to see that that value changes in the environment. While that is stopping and restarting, there is another file when we talk about logs building up. ThingWorx itself actually does its own rotation, right? If you should be aware of that, but that's in, I shut it down, in logging subsystem. There's some settings for logging in logging subsystem and platform subsystem, but those are in the platform. These, because they're specifically to Tomcat, it's really required to set them up in Tomcat. We looked already at the log rotation and purging for the GC logs. That was set up, 10 max files. Let's bring that back up. So here we're talking about the Tomcat specific logs. We just looked at the access logs. Now let's look at the, it's called the Julie log appender. So here the logging.properties file, which Tomcat uses for its logging configuration. And this is in the Tomcat, the Apache Tomcat conf folder. Normally is logging.properties file, but here you can see we've got a J2 file. So we're going to render this at start time. And so what I've done is I've added for each one of these async file handlers, I've added this max days parameter. It's the same thing as the valve. It's in there, it's a parameter, but for some odd reason, I don't know why, it's not set. So you get an infinite time retention. So here it's the exact same configuration. So considering I've just changed this to 3 days, basically I should see my Tomcat log rotation and retention go from the 60 days down to 30 days. No, 3 days. Okay, it's getting started. And so I'm not actually going to open up the file. I think you believe me. And we'll get into validating that in a second. So yeah, purging those logs, making sure that you've got rotation on those logs is pretty important, right? Because you don't want to have that surprise, and you certainly don't want to be in a situation where your application needs disk space to retrieve some files or to do some work, and it's all filled up with logs that have been accruing for a couple of years. Okay, so we looked at a configuration tweak using variables previously. Now we're going to have a look at some of these things using files. Now this is where it gets a little bit more complicated, but we're going to dive in and have a look. So we looked at this file previously, the platform settings, customer overrides.json j2. This is essentially where we're going to need to map any of the platform settings overrides that we want to make it into the platform settings. And so we're just going to maintain the structure here, as I've already got a base for us. And we're going to use an example in alignment with what we were just looking at with ThingWorx persistence provider. It's possible that you might want to make some of those configuration changes to some of these other parameters in here that are a little bit further down, maybe for something like the value stream processor settings. Value stream processor is handling all of the logged properties. And we can see we've got some flush settings configurations here. We've got number of processing threads. We've got some producer timeout queue size. So, I mean, let's try to change the queue size and the number of processing threads. So to do that, we're going to start by looking for the help. Come into the ThingWorx Help Center for platform settings. Configuration details. And here we essentially have all the configuration possibilities of the platform settings. And we see the section for MS-SQL persistence provider package connection information. This is what we were just looking at right here. And here we've got about, I don't know, 6 or 7. And you can see there's a lot more options if we did want to put some more in. Things like timeouts, if we wanted to query the timeouts, those would be good ones to potentially include in our configuration file so that they could be have configurations changed with variables. But as I said, we're going to focus on these value stream processor settings. So let's just copy this section and let's bring it over here and include it here like this and check the alignment. And it is in alignment in the same level as the connection information block. And so connection information block, we look good. Max wait time, queue size. So for the sake of this, we're just going to leave those ones as hard-coded defaults, as this is kind of what they are today anyway. And this 50,000, I'm going to take one of these kind of statements here and paste it in here and say ThingWorx database max queue size. There we go. Default is 500,000. Okay, there are no quotes around this. So that should be good. Max queue size. Database. Number of processing threads, 5 as the default. And okay, so we saved that, and now let's go and deploy this. Didn't set any of those, so those are actually just the defaults. I need to set them. So we're going to take the processing threads here. I'm just going to change the default here to 10. You get the idea that we can wire them through. No, I will wire it through. Okay. Database helper thread. So here we have this one. Queue size 50,000. There we go. And let's change that to 100,000. And this one to 10. Okay. Now we need to get those into here. Docker compose to wire them through. Okay, ThingWorx persistence provider settings. $500,000, and this is 5. And okay. So we've got those 10 there and 100,000. And here we've got defaults in the Docker Compose of the actual defaults, 5 and 500,000. Over here, we've included the lines into the platform settings customer of res JSON J2. And we've still got the original defaults in here. So let's go ahead and deploy this now. Okay, you probably saw me make that mistake on purpose. But here is exactly the example that I was referring to previously. When it tries to do the JQ merge of all the different JSON files that it's rendered, it's saying expected separator between values at line 419, column 18. So the column 18 is legit. The line 419, it's very hard for us to relate to that. Right now, and what we're doing, I mean, I know exactly which file that I've just changed that I'm applying this to, so it's kind of easy to go back and know where I've just added a few things, and I can just look at the code and sort of see what's going on. But when you're making a lot of changes at once, or you're trying to manage this in dev stages, this is extremely difficult to troubleshoot, also because you'll note that the pod is terminated, so we can't even go into the storage to get the generated files, the rendered files. So this is where we're going to get into, we're going to pause on this actual configuration change that we want to make, and we're going to look at some of the next steps, which are platform settings validation and container runtime debugging. So our goal is obviously to make those two things work, and we got some error there, and configuration tweaks. We're also going to look at another one. We're going to come back to that in a second. We're going to look at another file, which is a server.xml.j2 configuration. I mean, this is kind of a spoiler. I've already built this file, so not really sure what we're going to add to it, but we're going to pretend, I think. We're going to pretend that we're adding something to this, whereas we're just going to create a syntax error in this when we come back to it. But here you can see that the server.xml.j2 is configuring the different HTTP port, HTTPS port. And here what I've done is I've created a number of statements to add some additional Tomcat connector parameters to the configuration, because as I've mentioned before, like these sorts of things, it's when you need them that they're not there. So this one, as an example, I had added to the product about a year ago, but this one, the next one, is not added to the product. So this is kind of one of those examples when you are actually tuning a system for performance. You know, you're going to want things like minimum spare threads or initial pool size or whatever you want to call it, to be able to tune how the system works. You don't want it hanging up all those threads and going back down to the default, which is 10. If you know that in a minute or two, you're going to have 100 users that are all coming in and they're going to need threads to be able to respond to their requests. So Here I've added this. We'll just look at this particular configuration, but in this, the rest of this file, I've tried to essentially surface a lot of other configurations that are going to get you farther to performance and farther in production use cases, like some of these things, which are really socket use optimizations. Some things like configuring the proxy server. Compression, this is a part of the product already. Some of the keep alive aspects. And what else do we have in here? I've also added this down here. This is leveraging the Docker debug variable. Normally these values are set to false for production scenarios because you don't want information like sensitive information leaked in thread dumps. But if you're trying to troubleshoot or debug an implementation or a deployment or something like that, this kind of information from the error report for Catalina can be quite valuable. So here I've just subbed in the Docker debug value. So as you are trying to debug something, you will get a little bit more verbosity from Catalina. Okay, so we're going to come back and we'll break this in a minute, but right now we've already broken the platform settings merge process. So we want to troubleshoot this. And this is where we get into the validator that I mentioned that I had prepared. So here I'm going to look for this Docker entry point replacement that I created over here. And we're just mounting in the Docker entry point that I've modified over top of the one that's in the container. And what this brings to the table is a number of things, but the main thing here is a validator. So this is the JQ merge stage here. And part of the reason this is a pain is that it prints the files afterwards, after it tries to merge it. So it tries to merge it here, and then it's going to print, if you have on Docker debug, it's going to print the resulting file. But if you never make it this far, then you really have no idea what's in the file. And this is where it's tricky to debug. So I decided to build a validator. And this is what this is right here. And the validator is going to do a number of things. For one, like we just saw for the final platform settings, if you have Docker debug set, the validation stage here is going to print out individually the files. So it's a for loop. It's going to go through each of those JSON files and is going to echo them to the console so that you can actually see what's contained within. So if you have 4 files and you can see that each of the files has what you expect in it, that's the first stage validation. But then also it does something kind of neat, which is empty. So this is going to essentially cause an error. If there is a JSON syntax, it's going to catch this error in the condition, and that error is then handled. We're going to print that it's invalid JSON. We're going to set the error message, and we're going to parse out the line number from that error message. We're going to put a little header saying the line number, and then we are going to number all of the lines in the file. So the file in question, we're going to put some line numbers on it. We're going to do this sed start to end is going to essentially look for a few lines before. So this is line where it was found minus 5 lines, and then the ending line plus 3 lines. So typically you want to see the context like leading up. You know, sometimes you'll have a syntax error that might be 2-3 lines before. It's typically not a problem with the lines after. So here I took 3 lines after and 5 lines before, and essentially just going to color then the lines in question so that, you know, they really jump out at us, and we have the error block in question so that, you know, once again, get to someone's eyes as quickly as possible where they should be spending their time looking. So this is the validator, and as I say, I'm just using the JQ command to check for validity and then doing some bash scripting. I'm going to jump quickly back over here to the compose file for a second and just use the opportunity to mention 2 variables in here. This one here, force color, and this one, Docker pseudo terminal. These two are kind of required in order to get the color. Force color is going to be for some of the more basic ANSI color coding, and then I can't remember which tool requires the force color, but then basically JQ, in order for it to use color, that was one of the -C. It uses color, but it's really got a sense that there's a terminal there. So this is what the Docker pseudo terminal does, is it's going to take the value for Docker debug. If you've specified that to be true, then it will also determine that this is true, so that you will get color on the JQ output. So once again, just make it simpler to be able to see things. We're going to make sure that we have those set. So Docker debug is false. What was that other one? We're going to keep that as false. And I just said that was called Docker pseudo terminal. So Docker PS EU terminal equals true. Okay, Docker pseudo terminal. So that will give us the color. I didn't want to turn on Docker debug just because I don't want that verbose. I guess, why don't I just do that? Let's just get rid of this and just set this to true. We're going to get a little bit of extra verbosity. As I'm mapping in my custom, what's it called? Docker entry point. My Docker entry point has a number of other tweaks, which I guess we should look at briefly. There's this terminate on error environment variable, which is actually going to tell the terminal that you shouldn't halt everything if you get an error, number one. And Docker trace, which is a lot of those logs that we saw going by, like all of these are kind of useless. These are, for someone who's building this image, that's very useful. So this is where, diagnostics and debugging tools are very role related, which this would have been helpful for the ThingWorx R&D team building this, but for most of everyone else, this is just excess verbosity that doesn't allow us to see what we're really looking for. So here I'm going to get rid of those with this Docker trace, and I'm going to wrap those in Docker trace. So if we want to see them, we enable Docker trace to true. By default, it is set to false. I guess I could even put that in here. Look, false. Voila. By default, it's false. And there's one more thing, this terminate on error. What we're going to do down here is normally this would execute, replace the shell with the Java command, taking process ID 1 of Catalina. But if we've said we don't want to terminate the pod, the container, if there's a failure on Tomcat, or if Tomcat exits, then we don't want to replace the terminal. We want to keep the shell. We want to keep the shell in control. And so here, this is going to execute Catalina. If there is an error code other than like non-zero exit code, then we're going to go down to these other lines, which essentially are just going to tell us that there was an error exiting, and it's going to sleep infinitely. So as we're debugging, this can be super valuable for us to be able to get into the container, to poke around a little bit and see what might be going on, without knowing that it's going to stop on us in a couple of seconds. So I'm going to make sure that is also set. Terminate on error should be false. And I also mentioned the configuration validator. So this does say validate configuration true. Docker trace, we don't want Docker trace. I'm going to set that to false. I'm also going to set this Docker debug pause to 3 seconds. There is I guess 4 seconds is fine. There's another one of the things, sometimes things can happen a little bit too quickly. So here I have a sleep. In a number of the sections, you can see here, as we're stepping through the container initialization process, I've just added a little bit of a delay so that, for example, here in the for loop, we're looking at each JSON file. It's going to validate, it's going to check it. If we have debug enabled, it's going to print out those contents. We need a chance to be able to look at it. This is what this pause is for. Gives us a little bit of pause time that we can quickly skim the screen and see what's going on before advancing, you can obviously set that to whatever you want. And I think we're ready to go. So let's go. It's still running. It's interesting. Didn't terminate. No, it did. Exited. Platform exited. So the Docker Compose was still running, but the container had already been terminated with this error. Okay, so now we have normally. I'm just going to quickly check that we mapped some of that stuff in that we needed. This new entry point. No license overrides. So we do have this customer overrides, this platform settings. We don't need this. Go. You can see I added some color to this so the things jump out. We see, because we have Docker debug enabled, for one, I have these cyan colored sections, so we get a little section heading so that we see which stage of the process we're actually getting through. So we would be able to identify that from our Docker files and looking at the entry point, knowing how far we're getting through before something failed, generating configuration files with template processor. Once we're finished generating the files, this is where the validator starts. And you can see here the validating syntax, template processor, invalid. So it tells us which file that we're looking at. So this is the, we have the file name in question. And because we're moving this forward, we're doing them step by step. We know what file has the problem in it. And you can see here parser expected separator between values at line 26. And there we have, I am just highlighting the line before line 26 as well as 26. You can see we're missing a comma, and this is kind of a super common type of mistake that you can make with these Jinja files, is because sometimes with all these quotes and double quotes and brackets and curly braces and these sorts of things, it's quite easy to forget a comma somewhere or add a comma somewhere. And this is going to catch it for you. I'm trying to think of another example that I could do. Actually, here's one. I think if I put a comma right there, it doesn't like that. So let's stop this. And this is a really handy, because there is a setting. I guess I could use it as an example, but here what I'm showing you is we are changing one of the configuration files, but there are some settings in the actual platform settings files themselves. If you don't provide the right value, then you will get this failure. Yeah, I'm not going to go looking for it. I think you get the point. But basically, they are rendering out, right? So here, this has been a value that's rendered out, and there's a comma in there. But if there is one of these types of values and you're expecting, or there needs to be a quote or a comma after it, if there isn't, then it will fail. And this is going to hold true for those other platform ones. And so this validator will also work for those. So I believe I just removed the error. No, I created another one. Okay, right. There you go. So, I mean, you can see, obviously, this is a setup. I know how to break it. But this is the kind of thing, if anyone's been through this sort of thing before, this is exactly the kind of thing that you can be pulling your hair out for hours trying to figure out what's going on, especially when you can't see some of the different things and maybe trying to do too many things at once without carefully stepping through some of these steps. So I just fixed that file, and let's close that down. I am kind of wondering why it didn't terminate on error. Kind of wondering why it didn't. It's interesting. Exit. Okay. I don't think it really matters. I think this is probably in my code that I'm exiting, forcefully exiting here. This is probably why it's closing here, whereas I'm kind of catching it at the end. If Tomcat fails, this actually wasn't Tomcat that failed, right? Because I'm failing on purpose, trying to do the fail fast so that it doesn't actually get to Tomcat, because if Tomcat fails, you're not going to have any idea what the issue is. This is probably why we're not getting to that pause. But that's fine. Let's get to that kind of pause mechanism where we're going to come back. Did we redeploy? No, we didn't redeploy. So we have Docker debug that's enabled. And we do have the don't terminate on error active, as well as we should be able to see the colored JSON files from those platform settings as they're merged together. You can see that I've decreased the verbosity of some of these log message, as well as adding the color so that things are a little bit more coherent in being able to follow along. This one was not on purpose. Not on purpose, but this is a good good test. Okay, so doesn't like that, comma. Okay, while it's coming up, we're going to kind of quickly switch over to the server XML. We are going to mount this in. I mentioned we're going to break it as well. It's complete. Where are we going to break it? You know what? Something that I've screwed up before is trying to put a comment in here. So let's just do this. We're inside of the connector block here. And you can't add an XML comment inside of a connector block. So I like comments to just kind of document some things. We're going to see what happened there. So here's the example of the colorized version of the output of each of the files. We get them one at a time, and JQ is colorizing them for us. It's telling us that they're valid, just so that not only can we confirm what's actually making in there, but we also can verify things like, do we have any secrets that are coming through, etc. So very, very handy. And then at the end, here it's doing the merge. Maybe it was scrolled too fast. We should have the last one, which is the merged file, right? Validating syntax. So it also validates the syntax of the merge file. So it's before merge as well as after merge. Probably not necessary, but also good to know that it is considered valid JSON before it even tries to start ThingWorx. And we're off to the races. It's running. So let's stop this again and come back here. We're going to break this. As I said, we have put this error in here, which is a comment within the connector block. We need to make sure that this server override is enabled as well. Okay. So we should mount that in, and we should get an error on that comment. So unfortunately, I didn't build a XML validator. The JSON, considering there's so many files that come together, I'd say that's really the hardest part, because of the fact that there's no coherence in the line number that is going to give you, whilst here, the line number that is going to give us in the XML file is pretty much lines up with what we're looking for in the file that we're modifying. So it's not so hard to troubleshoot or debug. I think we can turn off the debugging. Do we need the debugging anymore? Not so sure. We'll leave it on. We can turn down the timing though. Okay, we're starting Catalina, deploying ThingWorx. It's not crashing. Why is it not crashing? Right, I did this in the HTTPS connector, not in the HTTP connector. And the HTTPS connector is not enabled. Actually, you know what? I'm not even sure if that's the error. I'm going to be really sure. The double dash will actually stop the double dash will stop the comment. So this is bad for two reasons. Don't want to waste time getting bad errors. Okay, so that's restarting. The next thing that we're going to look at after this, we talked about logging. There's only one thing we didn't talk about, I believe. Yeah, we still need a demo on that container pause. There are a couple things more to look at. Okay. Okay, there we go. So here we have thread, a stack trace, right? Fatal, severe error, Tomcat util digester, fatal error at line 47, column 15. So this is what I was saying. It is pretty good at giving us where. Line number 47, once again, element type is connector, and then it's saying must be followed by either attribute specification or this. Okay, and then so here is what I was referring to. We've told the entry point to catch this scenario, and so it has exited, and so we are pausing indefinitely just to sort of wait here with the anticipation that we can go in and we can have a look at the file and to see what the file looks like. Because this was what? This was the server XML, BT. So this is over here, conf, and then we have server XML. Okay. So here I'm kind of looking at the file and I see this. I guess I can even go something like okay, so it said it was at line number 47. Yeah, so this is one of those examples where it actually was triggered earlier, but it's manifesting, it's seeing it at line 47. Anyway, we know this is our issue. It's given us the chance to come into the container, to look around, to have a look. It'd be nice to have a validator. There are no tools that I can use in the pod to actually do that validation, though. So we kind of need an XML lint tool to be able to do what I did with the JSON. But that's fine. Let's stop this. We know what our error is. There is another little trick that I built into this, however, and that's at the end down here. If the Docker pseudo terminal variable is set, which would mean that, we're running on Docker using this compose file that I proposed here, because this is mapping in the Docker debug over to the Docker pseudo terminal. So if that is true, then what it's going to try to do, it's going to assume that we actually have this file repository root ThingWorx file storage mapped in to a local folder. And this local folder is right here, this repository folder. And this was at the bottom here. And I'm preemptively mapping this in, because if you wanted to do any dev or testing using a different file repository root than the standard ThingWorx storage one, then all you need to do is you change this variable. That's going to change the platform settings, which will have the files come here, but I can't really put a conditional operator around this in the Docker Compose. So I just pre-mount it. It's pre-mounted, and the question is, what do you want to use it for? And here I'm just using it for something else, because we have this mapping between the container and our working directory here. Well, if it's in debug mode and we're trying to get to the bottom of this issue, what's going on with our XML, our server XML J2, I'm going to copy these files over into this folder in repository, so that at each iteration we're actually catching the rendered files, and we're bringing them over here. So now I'm using VS Code, and I can just open up the server XML, and I can see in here what's going on. Yeah, I guess I must have restarted it. Anyway, I can see in here the actual rendered file. So here it's got colorized, it's got syntax checking. So although we don't have a linter on the container, I can use the linter on this other thing, VS Code. So that's just a little bit of another tool that I added in there. And then what else? So that should be able to start correctly with that new server XML. And I think there's one last thing to cover, which is this validation.properties file. In case you've never seen this file before, this is part of Tomcat's ES API, Enterprise Security API, that's leveraging some what are called OWASP top 10 rules for validating HTTP requests. And so it's looking for a number of things to validate against. Like here it's saying, for example, the HTTP scheme that are allowed are HTTP and HTTPS. And really it's just putting some guardrails around a lot of things that people might try to circumvent, things to do something that the web server is not expecting. And so these rules are there to warn you that that might be happening. However, this causes a lot of application log error messages, warn messages to come up that are essentially false alarms. They can take up a lot of space, and frankly, they dilute the logs, making it harder to actually sort of see the log messages that are relevant and that we want to get to, as well as taking persistence disk I/O. So this cookie one is one of the ones that comes up all the time. This one right here, header value cookie. So this is maybe the most common rule that is triggered, and the reason it's triggered is because of the fact that there is a character not in this list that is coming in to a cookie value to Tomcat. And we typically see this when there's observability tools like Dynatrace is notorious for adding some special characters, maybe a pipe, maybe a $sign. And you can see, for example, there is no $sign in this list. So $sign is something that a lot of people have to add to this configuration. Over the years, Tomcat is improving these lists with additional rules, and what I tried to do is to essentially wire this up in a way, as opposed to providing a pre-built file like this. The problem is maintainability with that. So what I've done is to instead, for that most common rule, can't really remember where it is. It's at the end. It's at the end. Yeah, okay. It looks like it is not in here. I need to, seems that's been lost in one of the version exchanges with someone. But basically, it is using a sed command. Sed, do we have any sed? Yeah, not there, not there. Yeah, it's been stripped out of here somehow. Using a sed command, it's basically variabilizing the configuration. So I should be able to find it in here. Validate. All right, well, I'll have to come back to this. It's basically allowing you to provide the string that you want to be added, so those missing characters, to the end of the validator. It is a little bit annoying because you've got to like double, triple, quadruple backslash stuff for them to get into that file, because this file is a regex, and you can see even here to backslash the dot, they're already using 2 backslashes. So considering we need to go through a layer of the M file, which is like 1 bash layer, then we've got the compose file, and then we've got to get it into the shell, and then we've got to get it into sed, which is going to modify this. I believe it's 4 to 1, so it's almost like 8 backslashes just to add 1 character. So this is one of those, trial and error in order to get it right. But the fact that I've variabilized this into the Docker entry point allows a runtime modifier, which can overwrite that. Let's check on our thing here. Our connector is still crashing. Why is it still crashing? We can quickly go in here now and look at our server XML. It might be actually that it's not able to overwrite those files. So we're going to just remove that. And let's check here. Apparently didn't remove it. Okay. That should go. And Tomcat. I didn't really add any cool Tomcat settings. I guess we can check some of these in here. I do have a section in here. All of these, for example, are just kind of tests that I did. If we uncomment this for the dynamic configuration of the Tomcat connectors, you can see here I am turning compression on. This is turned off by default. I'm also setting this access logging pattern. This is the default that's in there anyway, so I think I can get rid of this. And Okay, so I mean, at this point, it's already merged everything. It's already run, so we should be able to see over here. No, we don't see the server.xml. Why is it not copying the server XML? Huh. Might have screwed this up, but okay, I need to have a look at that. In any case, we'll go into the pod instead. And we want to see the apt conf server.xml. You can see here that I've removed my comment. And I also have some of these things: keep alive, timeout, bind address, bind on init, TCP no delay. So basically, if any of these values are set, they're going to expose the particular configuration parameter, and they're going to fill in the provided value. So as you can see, we get a nice and configurable connector. Once this has all been set up and tested, which was somewhat of a pain, but now that it's done, it's very easy to modify some of the runtime parameters, do some different tests. And this is exactly the kind of situation for whether it be a dev or whether it be QA or tester that's super valuable and helpful for them, because they can make quick changes to the environment in a matter of minutes, and that then supports further, whether it be load testing, stress testing, sizing, configuration changes, or what have you, right? The intention is to make these things reliable, manageable, trackable, source controlled, verified. And this is what we've done here. So this is perhaps the longest video that I have ever done. I would say this is kind of encompassing a lot of years of experience from a different variety of areas, and hopefully it can be quite valuable. As I say, this is not intended to only be valuable for those who are using containers, because we are touching on a lot of other aspects. However, I hoped to have shared some of the aspects that you should be thinking about when you are putting any application into production, and ensuring that at some point or other you have these types of things mastered. Don't hesitate to put your comments and questions in the comments below. And take care. See you next time.